Welcome back to This Old Jalopy and Project EVO Speedwagon. Yep, that is what I've decided to call it. Or maybe I'll dress it up like a junior version of the Ghostbusters Ectomobile and call it the Electromobile. If you're new to this channel, what I'm doing is I'm converting my 1962 Mercury Comet to electric. So far in this series I have actually not done much of anything at all yet. Mostly just planning, disassembly, and testing. But that is all about to change. Okay, what we have here on the bench in front of me, these are the ends to the Didion tube axle that I'm building. And if the word Didion tube is foreign to you, go check out my previous video. I explain it all in detail. But the way it works are these are the ends, like I just said, and then a large U-shaped tube will connect them rigidly, but also go around the motor and gearbox. And I'm going to have to build mounts for the motor and gearbox in this video, as well as connecting the brakes and a lot more work to be done. So there's gonna be a lot of metal fabrication in this video, a lot of flying sparks. So get ready. And let's start off with building these. Here's how I built them. Okay, I'm starting out with the front hubs from a Nissan Leaf. You could also use Tesla hubs, but I'm using the Nissan Leaf ones, and I chose a 4x6 section of box tube. And in hindsight, I wish I went with a 5x5. It would have made fitting the brakes a little bit easier. But 4x6 worked out good. I'm just taking some basic measurements of them because I have to send them to Send Cut Send. And I know what you're thinking. This video must be sponsored. No, it's not. I am not sponsored. And if it was, I would not be showing you what I'm about to show you next, because they hilariously sent me the wrong parts. These are supposed to be 5.5 inches wide, and they're only 2.5 inches wide. Comically small. And they did fix it, though. They sent me the right parts after all. But I guess that makes it, it would make it send, cut, send, wouldn't it? I'm preparing the box tube to be cut now. I'm going to cut it diagonally, as you'll see in a minute. But first I needed to get a general idea of how long the bottom section needed to be. And for me, that was about 6.5 or 7 inches. And I don't know if you've seen those other YouTube videos where the guy can just break the piece of metal in half with his bare hands, but it's a lot harder than it looks. Alright, so I'm welding this hub mounting surface flange here to the 4x6 steel tube. And if you've ever tack welded two pieces together, you'll know that after your first weld, it comes out of alignment a little bit, because when that weld cools, it'll pull down, and then you'll have opened up a gap on the other side. And of course, this needs to be absolutely perfectly square, because otherwise the alignment of the wheels will be off. They'll be toed in, toed out, or the camber will be wrong. So here is what I have done. I've got a perfectly square block of wood here that I squared up on a table saw. And I've screwed the flange to the block of wood so it could fit in here. Then I can use all these clamps here and this straight edge, as well as the table surface, to clamp it all really tightly together. And I also want to have a little bit, I want this to sit just a little bit proud, so they have a really good surface to weld to, while also still fitting inside the square tube, which will give you some good strength. So let's clamp it all together, and I'll show you how that works. Alright, it's good. It is perfectly square. Right there. And right there. And in this dimension too. course, I can't use this welder for welding it in place because this is not heavy duty enough, not hot enough. Now begins the process of cleaning this thing up. Okay, let's talk about brakes now. Brake rotors and calipers, these are for a 2005 Honda Accord. And what I did is I cut up these little tabs and then I bolted everything together, as you can see here. Then I tack welded it in with my MIG welder, disassembled, and then welded everything solid with my stick welder. So here's one of the tabs, and there's the other tab there. And that is made out of 3/8 inch steel plate. Okay, another point to make about the rear brakes and why I'm using these Honda Accord brakes is it has a handy mechanism for a parking brake. This here is like cable actuated parking brake instead of hydraulic or drum brake. The Nissan one had like a drum brake inside this part of the rotor, and that wouldn't have worked for me at all. And the reason why the parking brake is important is because I don't have a park setting in the car. So if you go back to the previous episode where I wired it up, there was drive, neutral, and reverse. And that's because with the Resolve controller, we're not able to use the parking feature on the Nissan Leaf motor and gearbox unit. The parking actuator needs to be controlled by a motor controller. And there is a guy on DIYelectriccars.com that has figured it out. Maybe I'll put a link down in the description to that if you're interested in it. Before I can finish building the Dion axle tube, I need to know two things. First, I need to know how wide to make it so that the wheels and tires are in the perfect spot inside the fenders. And second, I need to know how much space to make for the motor and the gearbox. At this point, I don't even know if the axle tube will go in front or behind the electric motor. So the old live axle needs to come out. Then I can get started mounting the motor. Before I can mount the motor, I need to separate it from the inverter and the PDU that is sitting on top. The PDU is the power delivery unit, and that's what contains the DC to DC converter and the charger and a few other things. And these are the bus bars connecting the inverter to the motor. So I just have to unscrew those. Then I can remove the 6 or so bolts connecting the motor to the inverter. And as you can see, though, it was easier said than done. It's called a motor.
Yeah, it is a motor. That's a motor.
Mm-hmm. What's this? What's that?
Tire. That.
That's a crane.
It is a train.
It is a crane. It's an engine crane.
Let's move it. Let's move it.
All right, let's move it.
The motorcycle.
I'm gonna move the crane.
The motorcycle.
The motor and the inverter did not want to separate from each other. There was these 4 locating pins that made it really tricky, because if you were lifting it and it was unbalanced just slightly, it would just not come apart. So I had to kind of reconfigure the way I was lifting it and use this adjustable thing for removing engines from cars. And it was still not wanting to come apart. I must have spent an hour just trying to pull these things apart. It was not fun. have the motor here. I have it lifted up as much as I can in this forward position. This is the way Nissan built it from the factory. The motor kind of sits in front of the gearbox, and the gearbox is back here, which means the motor needs to be pushed pretty far forward this way. However, it is possible to spin the motor in reverse. So let's turn it around now and see if it fits any better. So of course, yeah, there's a lot more room now, and I can lift it up several more inches. Okay, I had the Nissan Leaf motor up here and lifted up into position, but it's in the reverse position. And you're going to think to yourself, well, won't the motor then always be running in reverse? You can actually flip the polarity. There's 3 wires going from the inverter to the motor. You flip 2 of those wires. And then on the motor, there's something called a resolver, and you open that up, and I think you flip 2 of the small little wires inside that as well, and apparently that's all there is to it. Alright, I'm gonna crack on. The front motor mount is done. Now I can work on the two rear motor mounts, but those go a lot quicker because I learned this neat new trick on YouTube. Check this out. Okay, I have everything tack welded in now, so all I have to do is snap my fingers and it will be finished welded. Hey, it didn't work. Oh, it stopped working. All right, follow me to the basement and we'll have to do this the old-fashioned way. To create the bushings, I used these universal polyurethane bushings from the parts store. They're a little too big and I don't have a lathe, so I spun them on the output shaft of an old AC motor and I used a Dremel tool to turn them down. And it worked pretty well. As I mentioned earlier in the video, my MIG welder is not hot enough to do metal this thick, so I'm using my stick welder, and it is much harder to weld. I don't think I've ever used a stick welder, but it makes MIG welding seem like a hot glue gun. Because with a stick welder, you have so much to worry about. You have to worry about the angle of your rod, how close the tip is to the workpiece, what kind of rod you're using. I'm using 70-14 1/8-inch thick rods, and you can see the results. By the way, these rear motor mount tubes are the way they are, the way I built them, because they're not just going to be holding up the motor. They're eventually going to be also holding up the inverter and the PDU and probably a small radiator as well. So that's why they go all the way back to the rear bumper area. Well, that was a lot of work, but now I can finally get those two measurements I mentioned at the beginning of this video. The distance between the hubs that will determine the overall length of the axle tube and the clearance needed around the gearbox and motor, and that will determine the shape of the connecting piece. So now that the gearbox and motor are mounted, let's get those measurements now. And I think the clearance needed around the gearbox and motor, I think that'll be easy to get. I can just kind of use my eye calipers, give myself a little bit of wiggle room. But to get the distance measurement, that's going to be a little bit trickier. What I'm going to do is I'm going to clamp these end pieces to the leaf springs. And then I'm going to try and bolt up the wheels to them, make some adjustments so that the wheels are perfectly in the middle between the leaf spring and the inside lip of the fender here, and then take my measurements. Okay. Let's see here. It's pretty close. Should just barely fit. But instead of just take a tape measure and just measure between them, what I'm going to do is I'm going to mark with a Sharpie the location of the leaf springs onto the ends here. Then drill out the hole for the locating bolt on the leaf spring packs. Then clamp them back on, then do the measurement. Here's the hole for the locating pin drilled, and the reason why it's so far this way, offset by 1.5 inches, is because that will allow me to effectively relocate the wheel with inside the wheel arch in the fender and help out with a lot of clearance problems I would otherwise have. And then these 4 holes are for the bolts holding down this plate this will clamp the axles to the leaf springs, and this also holds the shocks. And it would want to be lined up with this locating hole, but I can't have bolts going through the side of the material here, so it's just as close to it as I can get. And then I will probably have to hog out this metal a little bit to get the other side of the bolt to fit. The time has come to take my measurement. And 50 5/8. And then part 2, measuring the clearance needed around the motor for the connecting bar. I said I'll just kind of use my eye calipers for this. So let's set up the tripod and get the tape measure out and see what we got. Okay. Looks to me to be about 7 inches. Alrighty, let's go cut some metal. Okay, what we have here is a piece of butcher block that I'm doing my layout on. And also this piece of wood is very flat and much flatter than the table that it's sitting on. Even so much there I had to put a shim in, like without that shim here. Yeah, that's how not flat this table is. So I would not want to use this for welding something that needs to be flat like an axle. And I also did my layout on here. You can see my Sharpie marks here. And what I've also done is marked the holes here for the locating pins and the leaf spring packs. And then measured with a tape measure from the end to end and made sure that it exactly matches what's in the car itself. Here is my metal piece of tube that I'm using, and it's 2.5 by 2.5 1/4-inch thick walls. And I've also been practicing my method for cutting metal, and all right, let's give it a go. Chop! Okay, that worked pretty well. I like that technique. I'm going to keep using it, I think. All right, now this one needs to be cut at a 45-degree angle. Chop! Okay, that was pretty good too, but it looks like my technique could be improved a little bit. There's just a little bit of a rough edge. So if I just cut it a little bit softer, I think that'd clean that up a little bit better. But seriously, I want to give a shout out to viewer and friend of the channel, Rowan, for cutting the pieces for me on his 50-year-old bandsaw. From this point on, I think it'll be pretty straightforward, and you know my routine by now. Tack them in with the MIG, and then weld them solid with the stick welder. And if you've been watching this video till this point, thank you so much, because I know it's been a long video, but I am almost done with this. And 10 minutes from now, I'll be done building the axle, finally. 10 minutes my time, 30 seconds your time, I'm sure. Here we go. Here's where all of that preparation is going to pay off. I'm using clamps to clamp the ends here to this straight edge. Therefore, they're perfectly parallel. What I need to do right now is weld in this piece here to the ends with the ends clamped down to the table, and they should be perfectly parallel. Oh yeah. Look what I have created! With my own bare hands! Oh, it's heavy. Oh, I have created a very heavy axle. Okay, I don't know if you can hear me, but I am all done welding, and I decided not to film any of it because you've seen it all by now. All right, I'm gonna let it cool off and clean it up, and we'll see how good I did. It's gotta be close to 100 pounds. All right, here it is. Here's the Didion axle tube. By the way, I have no idea if I'm saying Didion right. Could be Didion. Who knows? All right, well, we can't finish the episode yet. There is one last thing to do. Put it in the car. Put the wheels on it. I don't know what I'm doing, so here goes nothing, I guess. And there it is in the vehicle. Okay, it is just a bit more forward than it needs to be by about 1 inch to clear the motor, but that will not be a problem. In fact, it might help give me a little bit of room to add a skid plate because the clearance will be quite low, and that aluminum casing is probably pretty fragile. So skid plate maybe in the next video. Let's put on the wheels now. Well guys, the time has come to remove the jack stands, put all the weight on the Didion axle, and hey guys, if the wheels fall off, literally, just remember, you're watching This Old Jalopy, so please subscribe. I'm ready. I am so ready. Let's do this. Okay, you got only about 1.5 inches of clearance in upward travel. So 1.5 inches, maybe 2 inches of clearance between this motor mount, this aluminum piece here, and the axle tube. And that might be a problem, but we'll just have to figure that out in the next episode. Well, I'm really liking the way it's sitting, but it looks like I'm going to have to invest in some good bump stops. And also, there's 2 glaring omissions from this video so far. The axle shafts, because I have the axle tube, but not the axle shafts. And new leaf springs, because I'm adding a lot of weight to the back, as well as all the batteries in the front. So, subscribe if you want to catch that next video. Make sure you don't miss it. Thanks for watching, guys. Okay, see you next time. I found my wireless microphone laying on the floor. Somehow it fell in my pocket and got crushed. This is the right one, the passenger. I keep getting the passenger and the driver's side mixed around. Oh, Jesus. Okay, it goes like this.